Hey algebra students, we are going to go over our test on inequalities. Since we don't have a lot of time to spend doing this in class, I've just made you a video. So I'm going to go over all the problems on the test one at a time. For number one, y minus 3 is greater than 11. You are going to need to see what's being done to y. They're subtracting 3, so I need to add 3 to both sides of the inequality. And we get y is greater than 14. On your number line, you do an open circle on 14, and then you draw a line that shows all the numbers bigger than 14. That's all of these numbers right here. Notice on my number line that I did not just draw a circle and a line, I labeled the numbers on the number line. You have to label the number that you start your graph at, and you also need to label a few numbers around it. For number 2, x over 5 is less than or equal to negative 2. X is being divided by 5, so I'm going to need to multiply both sides by 5. When I do that, I get x is less than or equal to negative 10. Note that I don't switch the sign on that one because I did not divide both sides by a negative number. My answer can be negative without having to switch the sign. We're looking at, did I multiply or divide both sides by a negative number? And I did not, so I'm not going to flip the sign. I need a closed circle at negative 10 because there's a line under the sign, and I need all the numbers smaller than negative 10, and that is this way. Once again, notice that I did label negative 10 and a few numbers around it on the number line. Number 3. 5n minus 3 is greater than or equal to negative 18. There's two things happening in this inequality. They're multiplying by 5 and they're subtracting 3. You always do the adding and subtracting first, so I need to add 3 to both sides of the inequality. The 3's cross off. I have 5n is greater than or equal to negative 15. Then n is being multiplied by 5, so I need to divide both sides by 5. And when I do that, I get n is greater than or equal to negative 3. Once again, I do not flip the sign because I did not divide by a negative number. I divided by a positive number. We need a closed circle at negative 3, and we need all of the numbers that are bigger than negative 3. That is this direction. For number 4, two things are happening to m. It's being multiplied by a negative 3, and there you are, subtracting 1. So I have to start by adding 1 to both sides. The 1's cross off. I have negative 3m is greater than 9. Then for my second step, I had a few students who thought that 3 was being subtracted here. It is not, because m and negative 3 are sitting right next to each other with no sign between them. That means they're being multiplied. M is being multiplied by a negative 3, so we have to divide by a negative 3. The negative 3's cross off, and I have m is greater than negative 3. Oh, I didn't flip the sign. I just divided by a negative number. That means that I need to make greater than less than. I just divided both sides of the inequality by a negative number. That is when you flip the sign. And this says I need all the numbers less than negative 3, so I need an open circle on negative 3, and these are all the numbers smaller than negative 3. Let me make sure I got them all right. It looks like I did. So go on to the next page. On this page, we did not have to graph our answers, which is great, but the inequalities are a little bit more complex. So let's go through these. Number 5 says 3 parentheses k minus 5 plus 9k is greater than or equal to negative 3. Before I can solve this for k, I have to do two things. I'm going to have to distribute, and then I'm going to have to combine like terms. When I distribute to get rid of these parentheses. So I give the 3 to the k and make it 3k. Write down the minus sign. Give the 3 to the 5, and 3 times 5 is 15. Then I write down the rest of the problem. Plus 9k is greater than or equal to negative 3. The next thing I need to do is to put the k terms together. I have 3k and I have 9k over here. That is a plus 9k. I should circle that plus sign too. 3k plus 9k makes 12k. And then write down the rest of the problem. We have minus 15 is greater than or equal to negative 3. What I had a lot of students do here was they tried to subtract 3k from here and here, as if they were subtracting 3k from both sides of the inequality. That's wrong, because if you put minus 3k here and here, you subtracted 3k twice from the same side of the inequality. If for some reason you want to subtract 3k, you have to subtract it on this side and on this side. So in this problem, it doesn't help you to do that because you don't have a k on the right side. You just need to combine these like terms. 3k plus 9k makes 12k. Now, they are subtracting 15. I have to get rid of that by adding 15 to both sides of the inequality. The 15s cross off. I have 12k is greater than or equal to. That makes 15 minus 3 is 12. And then k is being multiplied by 12, so I have to divide both sides of the inequality by 12. And I get k is greater than or equal to 12 divided by 12 is 1. That's number 5. You can pause it if you have to, but I'm going to keep going, so I'm going to erase. Number 6 is 30 is greater than negative parentheses 5z plus 15 end of parentheses plus 10z. This looks like a long problem. And just like in the last one, I'm going to have to distribute to get rid of these parentheses. I need to distribute this negative sign. Another thing I want to point out about this problem is this is the right and left sides of the inequality. This is the left side. This is the right side. Usually this big part is on the left. In this case, they put it on the right, and that's okay. So we need to look at the side where the variable's on and simplify it as much as possible. I need to get rid of these parentheses, so I'm going to distribute the negative sign. I'm going to make this negative 5z plus, give the negative to the 15, negative 15. Another way of writing plus a negative 15 is just to write minus 15. That's a more simple way of writing it. Now we write down everything else from the problem. There's a plus 10z over here that we need to write down, and we need to write down this side of the inequality. 30 is greater than. Next, we have to combine like terms. I have a term that has 5z. I have a term, that has a z in it, and I have a term that has a z in it here. I can put those z's together. If I have 10 z's and I owe somebody 5 z's, I'm going to give them 5 z's, and I will have 5 left. 5 z's is what you get when you combine 10z minus 5z. And then I have this left, minus 15. I have the sign and the number that's on the left side. And now I can solve this like a regular inequality. They're subtracting 15. I need to add 15 to both sides. I get 45 on the left is greater than, the 15s cross off, 5z. Z is being multiplied by 5, so I have to divide both sides by 5. 45 divided by 5 is 9. So the answer is 9 is greater than z, or if you flip this over so that the z is on the left and the 9 is on the right, that's fine as long as you flipped the sign. I would accept either of these answers for this problem. 9 is greater than z, or z is less than 9. The next problem is a compound inequality that I ask you to solve and also write in interval notation. So we have to solve negative 3 wrong color, -3 is less than or equal to m minus 4 is less than -1. To solve this compound inequality, we have to turn this into two problems. We need to do this half of the problem. -3 is less than or equal to m minus 4. Then we have to do this part of the problem. M minus 4 is less than -1. And this is one of those and situations. And I did not take off if you mixed up the ands and the ors. Let's see, so we have to solve these two one-step inequalities. They are subtracting 4, so I have to add 4 to both sides. The 4's cross off, I get m. I get to keep the same sign. -3 plus 4 is 1. 1 is less than or equal to m, or you could flip this around and say m is greater than or equal to 1. Either of these answers is fine, but that's only half the problem. Some of you did this and stopped. We still have to solve this equation. They're subtracting 4, so we have to add 4 to both sides. We get m is less than 3. So you would have one of these two things plus this answer. Together make the answer. I would write these two would be my answer. Now for interval notation. Before I write interval notation, I always like to do the graph. And you didn't have to do the graph for this one, but I think this is going to help me see what the interval notation is going to be. We need m is greater than or equal to 1 and m is less than 3. So we will need, here's 0, 1, 2, 3, 4. We need all of the numbers that are greater than or equal to 1. Here's 1. All the numbers greater than 1 go this way. And we need all the numbers less than 3. Open circle on 3, and the numbers less than 3 go that way. This is an and situation. So this is one of those where you have two dots and everything in between. This helps me to write this in interval notation because now I can just read this from left to right. Let's see. The number 1 is where the line begins, and that is included. So we put a bracket, comma. The line ends at the number 3, and 3 is not included, so we put a parenthesis. So this is the interval notation. The last problem on this page is a compound or. It says 3t is less than -9 or -4t plus 5 is less than 1. So we have to solve both of these inequalities to get the answer. This one is easy because it's just one step. T is being multiplied by 3, so I will divide by 3. I get t is less than -3. Or the other part of the answer is to solve this one. Some of you left that as the answer, which is only half the problem. We need to solve this half now. They're adding 5, so I need to subtract 5. The 5's cross off. We have -4t is less than 1 minus 5 is -4. Now, t is being multiplied by a -4, so I'm going to divide both sides by a -4. The -4's cross off, and I have t on the left, 1 on the right, and since I just divided both sides by a negative number, I have to switch the sign. Let me make sure I got the answer right. T is less than -3, t is greater than 1. That is correct. We did not have to graph it, so we can go on to the last page. Last page is on absolute value. For number 9, we have the absolute value of x minus 6 equals 2. This is not an inequality, it's an equation. That's going to be important at the end when we graph it. So let's solve this equation. First, we have to get rid of everything outside of the absolute value. They're subtracting 6, so we're going to have to add 6 to both sides of this equation. The 6's cross off. I have absolute value of x equals 8. Some of you got this far and you just said that the answer is 8, but you forgot there's another number you could put here where if you take the absolute value of it, it gives you a positive 8, and that's negative 8. So x can be equal to 8 or negative 8. You can put an 8 here. The absolute value of 8 is 8. But you can also put a negative 8 here. The absolute value of negative 8 is positive 8. And then to graph this, you had to draw a number line that went from negative 8 to positive 8. And you've got to have those numbers in between. How about if we count by twos? Negative 8, negative 6, negative 4, negative 2. 2, 4, 6, 8. Let me see. We need a closed circle on 8. To graph the number 8, if you just want to graph one number, you just put a dot on it. X is equal to 8 means you put a closed dot on 8. X is equal to negative 8 means you put a closed dot on negative 8. And that's it. You do not draw a line in between these dots like this. If you drew this line here, what you did was you graphed all of the numbers that are greater than negative 8 and less than 8. And that's not the answer. We don't want the answer to be negative 2. We don't want the answer to be negative 6 or 4. The only answers to this equation, because it's an equation with an equal sign, not an inequality with greater than or less than signs. We only want dots on the line. So that was that problem. Number 10 was a lot easier than it looked. It says the absolute value of y equals negative 4. You just needed to think about that one. What number can I put here where if I take the absolute value of it, I get a negative number? There is no such number. You would not say that the answer is 4 and negative 4. If I put a 4 here, the absolute value of 4 is positive 4, not negative 4. If I put a negative 4 here, the absolute value of negative 4 is positive 4, not negative 4. So the answer to number 10 is there is no answer. This is the symbol for empty set, which means there is no answer. Number 11. We are almost done, kids. Number 11 is absolute value m minus 2 is greater than or equal to 4.2. For this problem, you need to look and see if anything is outside of the absolute value. There's nothing outside of it. So that means we're ready to split this into two answers. Just like we did with the one where we split it into 8 and negative 8, we have to split this absolute value into 2. But we're going to take what's inside, m minus 2, and we're going to write down exactly what we see over here. It's greater than or equal to 4.2. Then we're also going to write down what's inside the absolute value, m minus 2, switch the sign, make it less than or equal to, and make this number negative. Just like in number 9 where we had 8 and negative 8. We do the same thing with the absolute value, but we switch the sign for the negative number. Now we solve these. They're subtracting 2, so we have to add 2. The 2's cross off. M is greater than or equal to 6.2. And for this one, they're subtracting 2, so we have to add 2. The 2's cross off. M is less than or equal to negative 2.2. And let me just make sure I got it right. I did. Oh, but we did have to graph this one. So on a line, you need to show all of the numbers that are greater than or equal to 6.2 and all the numbers that are less than or equal to negative 2.2. I believe this is an OR situation, isn't it? This is an OR, yes. I said and, but I was mistaken. It's or, but I did not take off if you mixed up the and the or, as long as you got the graph right. Let's start with this one. We need all of the numbers greater than or equal to 6.2. So here's 0, 1, 2, 3, 4, 5, 6. There's 6. There's 7. 6.2 would be just after 6. We need a closed dot on 6.2. And we need all of the numbers that are bigger than 6.2. So that is all of these numbers right there. That's only half the graph, though. We also have to graph this. M is less than or equal to negative 2.2. So let's find negative 2.2. Negative 1, negative 2, negative 3. Negative 2.2 is right here. I need a closed dot on negative 2.2. And I need all of the numbers smaller than negative 2.2. That is all of these numbers right here. That was number 11. Last but not least, we have number 12. For number 12, we have 3 absolute value, n minus 1, is less than 6. Before we can split the problem in two, we have to get rid of everything that's outside of the absolute value. The absolute value is being multiplied by 3, so I'm going to have to divide both sides of this inequality by 3. The 3's cross off. I have absolute value, n minus 1, is less than 6 divided by 3 is 2. Now, I can split this inequality in half like I did in the last problem. You write down what's inside, n minus 1. Write down what's outside, is less than 2. Then for the other half of the problem, you write down what's inside, you flip the sign, and you make that number negative. Now we graph it. I'm sorry, we don't graph it, we solve it. They're subtracting 1, so I need to add 1 to both sides. We get n is less than 3. And this is an and problem. Let's see, they're subtracting 1, so I need to add 1 to both sides. And I get n is greater than negative 1. Make sure I got them right. And I did. We did not have to graph this, so we are done. For the bonus problem, I did solve that problem correctly. The problem was 3x plus 5 is less than 3x plus 12. And I solved it. I'm not going to write down what I wrote on here. You can all see it on your own test. But the answer I eventually got is 15 is less than 12. That's the answer I ended up getting. I ended up subtracting 3x from both sides, and that got rid of all of the x's. All I was left with is this statement. 15 is less than 12. Is 15 less than 12? No, it's not. Not last time I checked. So this is a false statement. That means that this inequality is false, that it's not a true thing. It's like saying 8 equals 5. It's just not true. Since this is false, the answer is there is no answer to this problem because this inequality is not a true inequality. It's a false one. It's a big lie. So there is no answer to that inequality. If you were to do this problem and if you had gotten a true statement here at the end where the variables go away and you're left with something that's true, then the answer is all real numbers. But in this case, the answer is false. So the answer is there is no answer. All right, I hope you enjoyed my video. I will see you all in class. Goodbye.